All right, I'm going to continue working through practice test 2 for Common Assessment 2. In number 1 and number 2, we talked about number properties and number sets. Number 3 and number 4, we're going to go through all sorts of steps to solve multi-step equations. And so we're going to find solution sets using multi-step equations and undoing operations in order to isolate variables. And so when we look at number 3, we have kind of a crazy looking equation possibly, but we have variables and we're trying to find the solution set for what value for x would make this a true statement. And we can see there's some things that are almost calling our name. And if you look here first, it looks like we have to use a distributive property first. And that's exactly what we're going to do. We're going to use the distributive property first and multiply that 4 through the parentheses. And we have 4 times 3x, which is 12x, and 4 times 4, which is 16. And so always our first step in a multi-step equation is simplify. So we're always going to simplify first. And what I mean by simplify is use the distributive property, and then if we can, combine like terms. Okay, so distributive property first and combine like terms. And that will make everything easier because we're simplifying. So as you can see on the left-hand side, we use the distributive property, but there are no like terms to combine. We can't add the 12x and the 16. We can't do that. On the right-hand side, we can't combine the 12x and the 16 there. So that is our first thing. We simplify first. And now what we can do is if we notice we have variables on each side of the equal sign. And so what I've been teaching is that we undo variables first. So we're going to undo these variables. Okay, so I have a 12x over here and I have a 12x over here. I'm going to undo one of them. And how do I undo a 12x? Simply take it away. So I'm going to take away a 12x. And if I take away a 12x from one side, I'm going to take away the 12x on the other side. And I'll be left with positive 16. And look what happened. The 12x cancels here, the 12x cancels here. What's going on? I'm left with a positive 16 over there. Holy moly, that's crazy. But if I undo variables first, it's going to be easy to see what I'm left with or what I need to do. But look what's happening here. Something strange just occurred. The variable canceled. And what we should know is that if our variable cancels, we have to ask a question. Does this make sense? So, does what's left make any sense? Read it out loud. 16 equals 16. Well, duh. That makes perfect sense, yes. So does it make sense? Absolutely. But what does that mean for the solution set? What it means is that no matter what we plug in for x, we are going to have a true statement. So it doesn't matter what we plug in for x, we're always going to have a true statement. Something on the left-hand side is equal to something on the right-hand side. So what this means is we have infinite solutions. Okay, so we have infinite solutions, or all real numbers are answers for x. All real numbers is the solution set. So we can call it infinite solutions, or we can call it all real numbers. All right, and that's what we can work with if the variable cancels. Now, what if what we had left didn't make any sense? What would be our solution set? So if we had something that didn't make any sense, the solution set would be no solutions. So we have to know the difference between infinite solutions and no solutions. That's going to be important. And now we can move on to number 4. We're going to use those same skills, and we'll move on to number 4, because this is a crazy looking equation. And so the first thing we can do, remember, is to simplify first. Use the distributive property and combine like terms. And the first mistake that students make is looking over here on the left-hand side. A lot of times students think that we need to multiply this negative 6 times the 4x minus 3. And if you read this out loud, you'll realize you're hearing yourself say minus 6, not times negative 6. So we do not multiply. But what can we do with these parentheses it's basically multiplying a 1, so nothing is happening. It's staying the same. So those parentheses stay the same. Another mistake is right here. Students think I have 19 minus 2, which is 17. And remember, we can't do that. We have to multiply, which is happening here, before we subtract, which is happening here. We have to multiply this minus 2 before we do anything else. So the 19 stays put for now because we are multiplying that minus 2. We have minus 2 times 2x, which is minus 4x, and then minus 2 times minus 5, which is plus 10. So from here we have lots of choices. But remember, the note that I want to leave you with is that we must simplify first. It's going to make things simpler, right? That's why we call it simplifying. So we're going to simplify first. That means we can combine like terms. On the left-hand side, 4x minus 3 minus 6. Well, minus 3 minus 6. We can subtract that. That will give us minus 9. On the right-hand side, we have a 19 and a plus 10. And a 19 and a plus 10 is 29. So we have things that we can do. Now that we have simplified, we've used the distributive property, we have combined like terms. Remember, I want you to undo variables. Okay, so undo variables first. Now, we can take away this 4x on both sides, or we can add this 4x on both sides. It doesn't matter. I'm going to add 4x on both sides. So see here, I have a minus 4x. I'm going to undo the variable. I'm going to add 4x to both sides. So if I add it there, I add it here. And I'll be left with 8x minus 9 equals 29. And now it's easy to see I have a two-step equation. So I'm going to undo minus 9 first. And then everything else is easy to follow. 29 plus 9 is 38. And then lastly, we can divide both sides by 8. And we have our solution set. X is equal to 38 over 8, which can be simplified. Both the top and the bottom are divisible by 2. So my value that I'm left with is 19 over 4, which is a little bit less than 5. But that is the value for x that would give us a true statement. So we have our solution there. And that's what I'm looking for when we're solving equations. Thank you.